In this video, we will learn how to identify the focus, vertex, and directrix given the equation of a parabola. All right, so for problem number 1, the vertex should be the most obvious. So we'll need the vertex, the focus, and the directrix. The vertex is just going to be the opposite of this one and the opposite of this one. So it's going to be 0, because it's just x squared, and then -5, 0, -5. For the focus and the directrix, you're going to want to do a sketch. Okay, that's just the way it is, so deal with it. So here comes a sketch. We've got the vertex at 0, -5. So 0, -5, 1, 2, 3, 4, 5. So here's my vertex right here. And we know that is this parabola going up, down, left, or right? Well, when the x is squared, that reminds me of good old y equals x squared, which definitely was a normal parabola. So this is not sideways, it's either up or down. And since this 8 is positive, it's going to be facing up. Okay, so I've already got my vertex there, so now I even know that it's up. So I know it's going to be doing this kind of a thing. The p-value is what I need now. See that 8? 4p is going to equal 8. That means p is 2, because I divided by 4 on both sides. All right, that p-value tells me where the focus goes. Up 2 from the vertex. All right, get it? Up 2. So 1, 2. So there's my focus right there. And that is the point 0, -3. Now the directrix will be in the opposite direction. Okay, so the directrix will be down 2, all right, from the vertex. So like 1, 2. The directrix will be down here. And you see how it's horizontal, so that's going to be y equals whatever this is. The vertex was at -5, so it's -6, -7. So y equals -7. Okay? Now, as I look at problem number 2, I'm not feeling this fraction. So please understand that if you have a over b and a over b and a over b, negative a over b is the same thing as a over negative b, which is the same thing as having the negative right in the middle. So you can put that negative wherever you want, is the point of that story. And right now what I want to do is to put the negative sign down here on the 28. That's to remind me that what I really want to do is multiply everything by -28 on both sides. That way the -28s cancel out. So I'm going to have y plus 4 squared is equal to -28 times x minus 4. Okay, so now it's looking more like what I'm used to. So is this parabola facing up, down, left, or right? Well, a normal parabola is like y equals x squared. All right, that's the first one we ever learned about. It looked like that. X would be squared. Here I have the y being squared. That tells me that this is sideways. All right, so it's either facing left or right. And since this is negative, that means this is facing to the left. Okay, so keep that in mind. How about that vertex, people? Let's talk vertex, shall we? So the vertex is going to come from right here, but be careful. You might be thinking -4, +4, but you'd be wrong. You have to be careful because first comes the x term. And x comes from the x part of the equation. So it's going to be +4 because of this. And then the y part of the equation gives me the y value. So it will be negative 4 because of that. Okay, so there's my vertex. Let's sketch that so far. All right, so here's my sketch. So 4, negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. So here's my vertex at 4, negative 4. Okay, that's my vertex. Now, I know this is facing left. So I know it's doing this type of thing because we already discussed it. So all I need is my p-value and I'll be on my way. So the p-value is going to come from this negative 28, don't you know? All right, because I know that 4p is going to equal the negative 28. If I divide both sides by 4, I'm going to get p is equal to negative 7. Okay, so that negative 7 tells me where to put the focus. I'm going to go left 7 from the vertex. Okay, so here I go. Right now, I'm over 4 to the right. So here I've gone 4 so far, and then I'll go an additional 5, 6, 7. So that'd be right there. Okay, now of course this is the point negative 3, comma, negative 4. So that's my focus. Now my directrix is going to have to be 7 in the other direction. All right, it's going to be encroaching on the space here, but so I'm already here at 4, so I'm going to go 7. So 1, 2, 3, 4, 5, 6, 7, because of the p-value. So here's my directrix over here. Okay, and if this is 4, then this is 5, 6, 7, 8, 9, 10, 11. All right? So a vertical line is x equals. So this is going to be x equals 11. Now for number 4, I do not have to complete the square because I've already got a binomial squared right here. But I do need to get parentheses over here, but I can do that by just factoring out the 2. Put it outside of parentheses. So that's going to leave behind x plus 3. Basically, I divided everything by 2, put it out front. Now, this is sort of backwards from what we've been doing so far this unit. So please understand that this is the same thing if I wrote it the other way around, as y minus 1 squared is equal to 2 times x plus 3. Same thing. So you should be able to glance at this and tell me the vertex immediately. Again, if you were thinking positive 1 comma negative 3, you'd be wrong. So be careful. Regardless of the order that we write it in, the x value has to come from the x part of the equation. So it's going to be negative 3 because of that, comma positive 1 because of that. So that is my vertex. So we might as well go on and graph that. Okay, so I've got negative 3 comma 1. So the point negative 3 comma 1 is like right there. So there's my vertex. Now I need the p-value, which I'm going to get from this. Now remember, this is 4p. So 4p is equal to 2. So if I take this and I divide both sides by 4, I'm going to get that p is equal to 1/2. Interesting. P is equal to 1/2. Wait a minute. This equation, is this going up, down, left, or right? Well, I'm seeing the y is squared, all right? A normal parabola has y equals x squared. That was the first parabola we ever learned. So when I see y squared, I know it's sideways. And because the 2 here is positive, that means it's going to be facing to the right. Okay, so looking at my vertex, and knowing that it's facing to the right, that means it's doing like this. Okay, now my p-value tells me where to put the focus though. Now that I know it's going to the right, I'm going to say, okay, how about to the right 1/2 of a unit? So that's going to put me right here. Okay, so that's negative 2.5. So that's why the focus is going to be negative 2.5, comma 1. All right, just like the vertex. Now all I need is the directrix. But you know the directrix is going to be the same distance on the opposite side. So still doing the p-value. So if I go to the opposite side, my directrix will be 1/2 to the left of the vertex. So with the vertex here at negative 3, then the directrix will be x equals negative 3.5. Okay? Vertical lines are always x equals. So that's it for number 4. All right, these problems on the back are pretty much the same thing, but they're making us draw a graph instead of just having to do a sketch. All right, we're doing a proper graph. But other than that, it's the same thing. At a glance, we know that the vertex is going to be 0, 0, because it's not x plus 3 squared is equal to 12 times y minus 1. If I had this going on, then the vertex would be negative 3, positive 1, opposite of this, opposite of that. But the absence of anything being added or subtracted means that it is in fact 0. Okay, so let's graph that so far. 0, 0, there it is. Now is this graph opening up, down, left, or right? Well, I see good old y equals x squared, so that means it's either up or down. And since the 12 is positive, that means it's going to be up. So right away, I know that it's doing something like this. Don't draw this yet, because we need more precision, but we know it's going to be facing up, so just keep that in mind. We need the p-value, so we can find the focus and the directrix. So see that 12? That tells us that 4p is equal to 12. If I were to take this and divide both sides by 4, that's going to give me that p is equal to 3. That means I'm going to go 3 up from the vertex. So here's my vertex, 1, 2, 3. So that means this is my focus. That's the point 0, 3. All right, it also tells me that I'm going to go 3 down for my directrix. Okay, so here's my directrix. And horizontal lines are always y equals, so this is the line y equals negative 3. Okay, so let's make our graph more precise by using the focus width. The focus width is 12, because see the 12 right there? So that means at the focus, there will be a width of 12. In other words, 6 to the right and 6 to the left. Okay, so this is a basic sketch of the parabola. All right, let's do one more example of this, and we'll call it a day for this video. If I were you, I would get rid of this fraction. Now, we can put this negative sign wherever we want, so I'm going to move it to the denominator, and that makes it clear that if I want to get rid of this, I'm going to multiply both sides by negative 16. All right, that way these negative 16s will cancel out, and that's going to leave me with y minus 4 squared is equal to negative 16 times x plus 2. So right away, you should be able to tell me the vertex. Be careful. If you're thinking positive 4 comma negative 2, you're wrong. Why are you wrong? Well, if you knew that, you probably would have said it right in the first place. So, silly question. I withdraw the question. You're doing it backwards, okay? Common mistake. Don't feel bad. The x-coordinate has to come from the x part of the equation. So, the negative 2 comes first from this. The y variable has to come from the y part of the equation. So, I'm going to put the positive 4 here. So there's my vertex. Might as well graph it. Negative 2, comma 4. Okay. Now, is this parabola facing up, down, left, or right? Well, if I see y equals x squared, I know that's normal. But instead, here, I've got y squared is equal to x. That means this is one of them there sideways parabolas. All right? Or I should say sideways parabola. So it's either going to be facing to the left or to the right. Because of the negative 16, that means it's facing to the left. So this will be facing to the left. So don't draw this yet, but look, we know that the parabola is like going like this. To find the focus, we need that p value. All right, see that negative 16? Keep an eye on that, because 4p has to equal negative 16. And we will divide both sides by 4, and that's going to give us that p is equal to negative 4. That tells us where to put the focus. All right, we knew it was going to the left. Now we know to go 4 to the left of the vertex. 1, 2, 3, 4. So there's my focus. All right, which is negative, let's see, negative 6, comma 4. All right, for the directrix, I'm still going to use this p-value, but I'm going to move in the opposite direction. So I'm going to move 4 to the right. So 1, 2, 3, 4. I shouldn't actually put a dot at all. Whoa. Just put your vertical line. All right, so that's a vertical line at 2. So that's x equals 2. All right, one last thing. All right, so we have to do one more little thing. Let's use the focal width to make this more accurate. The focal width is 16. Ignore the negative sign. That means at the focus, the parabola will be 16 wide. So that means 8 up and 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's a little bit off the grid. And then the other way. It's 4, 5, 6, 7, 8. All right, so there you go. Here endeth the lesson.